is Daryl, and this is Programming in Any Language. Logical operators. There's 3 of them, and one of them you shouldn't use. This should be pretty easy. Logical operators allow you to connect multiple Boolean expressions together. The operators are and, or, and not. That's it. And you use these same operators in everyday English. Example, if I can make $1 million and it's legal, sign me up. 2 Booleans are being used here. Can I make $1 million is one. Is it legal? That's the other. Here's another one. Is it fun, cheap, and last all day? There's 3 Booleans. If all 3 are true, you might want to do whatever it is. Let's take a closer look at this. Logical operators. Okay, we've seen those multiple decisions happen with a nested if, the if, else, if, and so on down the line, where we can ask a couple different questions and get those answers. You can also put those into one single statement. This is sometimes a good idea, sometimes not so good an idea, because it can be confusing, yet it can also simplify things too. It depends on the question. Here's what you can do. You basically have 3 operators, and one of them you shouldn't even use. And they are the logical and operator, or the logical or operator. Allows you to combine multiple Boolean expressions and create a compound expression. So the double ampersand is the and operator, and the double bars are the or operator. You also have the not operator, which is an exclamation point, which reverses the truth of the Boolean expression. So and, both expressions must be true for the compound expression to be true. So is female and is over the age of 30. If both those are true, you can move forward and do something. The or statement, one or both sub-expressions must be true for the compound expression to be true. So is female or is greater than 30, either one of those is true, you can go ahead and it's a true statement. The not one negates everything. The not negates the reverse value to its opposite one. Yeah, here's a better expression. X is greater than Y and A is less than B. If is A greater than Y and A is less than B, they're going to have to be true in order to be there. The or A is X is set equal to Y, or X is set equal to Z. So if X is set equal to either one of these things, it's going to be true and it'll go forward. But X is greater than Y, not. So we're saying if X is greater than Y, which is a true statement, then it's a false statement. It's going to reverse the condition there. This guy is dangerous. You use them in very, very rare circumstances, but it basically never reads well, and it doesn't work well for your program. Always try to look at a true statement when you're actually doing this kind of thing. Okay, so we were into the logical operators here. I'm going to go down. I've got the same slide here: the not, the and the or. There's only 3, and they are listed in the order of precedence, like the math operators, or how they are evaluated. Not is evaluated first, followed by and then an or. And like the math operator, you can use a parentheses, and they make sense to use, because when you start working with compound statements, they're hard to read unless you actually do put parentheses in there so you can see the English in it and how it actually works. And some examples might be like this. This is the same example going across here. We might express our compound condition to find all the women Republican votes over the age of 65 as age is greater than or equal to 65, and sex is set equal to female, and status is equal to Republican. This is kind of easy to read. You can kind of look, this is going to be true, and this is going to be true, and this is going to be true. In order for all 3 of these to be true, that's the only way you're going to be able to go into the next statement and move forward on there. But you can also define it this way: not age less than 65, and sex is set equal to female, and status equal to Republican. Yeah, okay, there's no parentheses here, and that not thing, not less than 65, and it's a little bit more confusing to read it this way. So you kind of want to work with the top one more like that. That not operator is just a nasty guy. Well, this is just as valid as the first statement and provide the same result. The not operator tends to be confusing when read. A good practice to avoid using an operator if you can. Another good practice is to employ the use of parentheses for clarity. You certainly want to do that. So here we're doing that. We still have that not in there again, and we put the parentheses around it. Not age less than 65. Okay, age is less than 65. Not. That means they're greater than. Okay, and sex is set equal to female, and status equal to Republican. So this helps clarify a little bit by putting that parentheses in there, but it's just trouble. It's much better to look at it like this. Set it to greater than or equal to. Make it all positive as you can move forward, and your statements will read better than that. When should you use these? Well, you could certainly use it in the application we just looked at, the loan application. Is the person been there more than 2 years and makes more than $40,000? Yes. Bang, give them the loan. Else, get out of here. We don't need it anymore. But if you want to specify why, then you say if it's, you can look at each one of these things that's failing. It was which one fails where. So let's take a look at that. The and operator, if the temperature is less than 20 and minutes is greater than 12, temperature is in the danger zone. Okay, the or operator, the temperature is less than 20 or the temperature is greater than 100, the temperature is in the danger zone. And the not operator, the temperature is greater than 100 not. This is below the maximum temperature. This one's a little screwy to read. These are truth tables. This is something that comes out of engineering school. And or and not operators are used in circuit design. And the engineers came up with truth tables to basically kind of see which way you're going on these things. And the interesting thing about it, when you look at an and expression, they're always false unless both are true. So one side is true, one side is false, it's a false. False, true, false, 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 false. True, true, it's true. So the only way an and operator can be true is if both sides are true. The or operator, true, true, false, true. If both are false, it's false. Otherwise, it's always true. An or operator is always true unless both sides are false. The not operator is the opposite of whatever it says. If it's true, then it's false. If it's false, then it's true, because it's a not operator. Don't like this guy. Get rid of him. Don't think about him. So as you can see, the and the or operator are quite useful. The not operator is there for any time you may need to negate a statement, but it's best not to use it. Employing parentheses is good practice for readability. Restate that. Employing parentheses is a must. It just helps clear things up. Now, let's take a look at that example we used in the last video, the loan approval routine. Here, we'll still use the if, else, if, but we'll add a compound statement and look at it two different ways. Once again, we have our little program here from last video we did, the loan qualifier, where we can put an annual salary and again, use the current job, and it runs like this, if you remember. Let's pop it on, run it. It's using the if, else, if. We'll put in $50,000 and put in 5 years on the job. Check qualification. You qualify for the loan, so it works just fine there. We're going to put in $30,000 and leave the 5. You do not qualify. Salary's too low. Okay, and we're going to go ahead and put in $50,000 again and put in 1 year. And we check qualifications. Not qualified, you're in the job too short. Okay, so that's not working. I mean, it's working just fine as it is. And if we look at the code, we can see that, once I get to it, we can see that we're looking at this piece right here, where it's using the if, else if, followed by an else statement to make that qualification based on the flowchart we looked at weeks ago. Now, I'm going to change this thing to a compound statement to make this thing work. So it's going to look the same to the user, but it's going to use a compound statement to make these decisions instead. So what I'm going to say is I'm going to basically put a extra parentheses in here. And I'm going to say if DBL salary is greater than or equal to 40,000. And then I'm going to say and DBL years is greater than or equal to 2. And end that with a parentheses. Now notice that both Booleans have to be surrounded by parentheses. I need this right in here, one right in here, and then one right in here. And that allows the salary is one Boolean, years is another Boolean, and that's surrounded by parentheses on top of it. So we have those things set up like that. This is now going to, if this side is true and this side is true, it's going to drop down to here, which indeed qualifies the user for a loan. So we're going to say you qualify for the loan. Then we're going to say else, and we're going to make another compound statement down here. We're going to say if the salary is greater than or equal to the minimum salary, or greater than or equal to 40,000, and DBL years is less than 2. Now we got the 2 already there. Then the user does not qualify for the loan, basically because minimum years not met. Otherwise, salary requirement not met. And we've got one little error here because we've got too many. We're missing a parenthesis right here. You got to put those, shrink those things in so you got them and everything is fine now. So now we can do a file save and do a run. And you'll notice that 50,000, 5, check qualifications, you qualify for the loan. No difference there at all. Now we're going to check at 50, we're going to leave it 50,000. We're going to set the 1 year. Check qualifications, minimum years not met. Okay, cool. Let's make it back to 5, but let's make this $30,000. And check the qualification. Salary requirement not met. So to the user, it works the same as it did before, but you're using a compound statement to make this thing work. Now, let's go one step further on this. We know this is working. We've got our compound statement here. This has to be true, and this has to be true for this to happen. And for here, we're looking at this has to be true, and this has to be true to allow the years not met. Otherwise, the salary is not going to be met. But let's change this. Instead of specifying why they didn't get the loan, what if we just left it as you didn't get the loan? We could change this to an if-else statement, period, just by leaving this compound statement up here and then taking all of this out and making it an else statement. In other words, we can simply say, you do not qualify for the loan. And we'll run it. Start it up. And just like before, we'll put in the 50,000 and we'll put in the 5 and qualification. You qualify for the loan. So everything is fine. The salary's right, the years are right, fine. Set it down to 30,000. Check. And you do not qualify for the loan. Just doesn't say why. It just says you do not qualify for the loan. Put it back to 50,000 and make this a 1. You do not qualify for the loan. So you don't either way, but it doesn't tell you why. But in some cases, that doesn't matter. You simply want to make it something very, very simple that you can actually use. So what you do is you have a compound statement right here, checking the salary and checking the years. And if this is true and this is true, you end up qualifying for the loan. Else, you don't qualify for the loan. You made it a simple if-else statement with a conditional statement, with this logical statement sitting right here making that work. So it's a couple ways you can do this. So using a compound statement allows you to declare the true side immediately. Whether or not you want to point out each false side is up to you, or up to what makes the program best. Notice we could actually slip back to an if-else condition by using the compound operator once to find the true pathway and basically ignore the false. And that's what we did in the second example. You'll find that as you continue to view these videos, the compound statements are a big help in input validation. We use them not necessarily to check the validity of data, but to check the reasonableness of data. What you need to take out of this video is and, or, and not are 3 logical operators. Not should be avoided. Compound statements can simplify your logic. See you next time. Thanks for watching, everyone. If you get a chance, please subscribe. We'll see you in the next video. Take care.